for the next 10 years, software engineers, software developers / engineers are one of the highest paying jobs, and the one with at least almost 20% growth in the next 10 years. So there is a huge demand. Why? Because more and more we use software. Back in the old days, we had our software on our desktops. Now we have laptops, we have handheld devices, we have like tablets, cell phones. They all use software. And guess what? We have our cars that now use software. While we're here, let me briefly introduce you to one of our students, Kadim. He's working in the lab. He's one of the best students we have, and he spends a lot of time in this lab. We're glad to have students here and have them studying, working, meeting with other students, and so on. My name is Professor Skevoulis. I'm a professor at Sandberg School of Computer Science and Information Systems, and also the director of the software engineering program. I've been teaching computer science and software engineering courses all my life. I started very early in my career as a PhD student in Chicago when I did my PhD, and I continued. I have quite a few publications out there. I have received grants from NSF, National Science Foundation, and to promote software engineering and formal methods. In particular, formal methods is the application of mathematics in the software engineering process. Software development and software engineering is based on what we call software development lifecycle. This is something that we do every day. I'll give you an example. Everybody, I guess, has used your navigator, right? What do? Your navigator locates you. Where are you at this particular moment? You input where you want to go. So the navigator knows where you're at and where you want to go. Then the navigator is going to move ahead and design a solution for you. And as a matter of fact, it will give you like maybe 2 or 3 possibilities, like, the fastest route to get there, something that you don't pay tolls, or something that you follow a scenic route or something like that. So then you choose the best approach, the best route, based on your needs, or you are the customer at this point. So once you do that, you have to implement that design. You have to drive or walk. All right, so once you drive, it's like implementing that design. Follow like the instructions, go straight, make right, make left, and things like that. And finally, when you get to your destination, what you do is like look around and say, have I reached my destination? Oh, yes, this is the correct address. There you go. That's what we do in software development. We collect the requirements from the user, we design 2 or 3 possible solutions, we pick the best one given the constraints under which we have to operate, and then we implement it. We use a programming language, Java, C++, Python, any programming language to implement. And once we're done, then we test the implementation, see, does it do what it's supposed to do? So pretty much, software engineering is something that, without even realizing, we do it in our everyday lives. It's very important to emphasize that software engineering also requires the development of soft skills. It's not, as I mentioned before, it's not like one person or 2 in a basement somewhere. You have to interact with customers. You have to talk to them. You have to negotiate with them. You have to convince them that your ideas about the design, about the coding, are the appropriate ones. So you need to be trained. That's why most of the courses are group work, based on group work, because we have to let students learn how to talk to people, go out there, make presentations, talk to people, convince them. It's a very exciting job because it's not only the technical aspect, the technical part. It's also the communication, the human-to-human communication, and the whole fun part of meetings and presentations and negotiations and so on. Software engineering now is offered in an online mode as well. The reason for that, many people had some at least concerns about the online nature of software engineering, but there should be no concern because either we like it or not, software development is distributed nowadays. There is no chance or very little chance to be all the developers to be in the same room, in the same building, on the same floor. No way. Nowadays you have a team in New York City, another team in Los Angeles, another team maybe in India or somewhere else in the world. And they have recently developed what we call 24/7 factory. So depending on the time zone, somebody is always working on the project. So it's like 24/7 development and progress. So online software engineering is where students read the materials at their own pace. They form groups, so they don't lose anything from the group work. By the way, software engineering is all about group work. There is no way to develop software, real software nowadays, alone. You have like 500, 1,000, or 3,000 developers working on projects. So it's impossible to be physically located in one location. So the same thing is true about software engineering. We have all the tools and the software. We have PowerPoint slides. We have video lectures available to students. We have Zoom, of course, for communications. And all teams, virtual teams, meet at their own time. And I think it's very convenient, especially for working professionals, because having work and family and all other kind of things, it's difficult to pick like a certain time, 6 to 9, to be downtown New York City to attend a class. And let alone the commuter costs and the time sacrifice and everything else. So that's what the online program does. This lab is one of the main focal points for our program. The lab has a library here, so students come in here, study and practice. It's myself primarily as the director of the program, and we have at least like 3 or 4 other professors that they teach on-site or online courses. 2 of them are former software engineering students who finished the program, got really good jobs out there, and one of them lives in Washington, D.C., and he's doing the online courses, of course. And the other one is like a software quality engineer in New York City. So we have like a wide variety of backgrounds and all kinds of areas, in all kinds of areas in software engineering. We have people that they get jobs at Google, for example, Facebook. We have, of course, financial sector, Bank of New York Mellon. That's a huge example. We have more than 250 graduates there. And pretty much any kind of software development industry. We have so many students that they have startups. We also allow students to take the IEEE certification, and that's an extra incentive, which I did not mention before. The IEEE certification makes sure that, and it's an outside body, of course, a well-known body of knowledge, and IEEE certifies that no matter what kind of degree, where did you get it, you are a certified software engineer. And as a matter of fact, and it's something that I'm very proud of, our program, our school and our program has been designated a registered education provider for IEEE, which means that IEEE visited us some time ago, and then they examined our program and they said, yes, it fulfills all the, it satisfies all the standards that we need, so students can get really solid education at Seindeberg School and the software engineering program.